Hi, and welcome to the Ideaspring Capital podcast, a show where we discuss the latest trends in technology, startups, and tech entrepreneurship in India. Today we have Deepak Agrawal, AVP at Ideaspring Capital, in conversation with Kamesh Raghavendra, Chief Product Officer at the Hive. A Goldman Sachs and IIT Madras alum, Kamesh works with entrepreneurs to address market segments in areas such as the Internet of Things, cybersecurity, enterprise applications, blockchain, decentralized apps, and financial services. In this episode, they discuss the fundamental difference between automation and AI-based automation, the industries being impacted, how it transforms the economics of enterprises, major advancements in cognitive modeling, and a whole lot more.
Thanks, Kamesh, for coming in and spending time today.
My pleasure.
I'm just going to start off with a very basic question about the fundamental difference between automation and AI-based automation, just to kind of differ between the two, the pre-programmed rules and the database simulated human thinking.
First of all, thanks for this opportunity, Deepak. Incidentally, this is my first podcast ever, so I'm a
great.
podcast newbie. Of course, I appreciate making this happen. So yes, essentially, automation is not a new topic. Automation has been a phenomenon since the 60s and 70s, starting from the industrial manufacturing type assembly operations. AI is also not new. People call this the fourth awakening of AI. AI has been a topic of research in computer science as early as in the 40s and 50s. The reason why this combination of AI and automation is picking up is because of the complexity of automation and the role AI can play in dealing with the complexity of automation. So traditional automation was very programmatic. You would have developers building very rigid rules, like the way you operate a robotic arm in a car assembly type use case. As automation started looking into more challenging use cases, this programmatic approach was no longer scalable. For example, automating speech recognition or automating face recognition in photographs and images and so on and so forth, where the number of combinations of possibilities is so high that it's not possible, it's not economically feasible to have a rigid programmatic approach. And therefore, there is an element of learning involved in automation. So this could be learning based on the way humans are performing a particular task, or learning by observing outcomes from the way a task is performed by a programmed AI-driven automation robot, or learning by using models built in a different task being reused in a slightly modified kind of task. So the element of learning giving the ability for dealing with intensely complex automation tasks created this opportunity for AI-driven automation. And therefore, every time you see a new product being recommended or a new film being recommended when you open Netflix, you can see the AI-driven automation playing a key role there. And that, therefore, created the next wave of use cases of automation in both kind of digital forms and in physical forms.
So which industries out of so many which are kind of getting impacted by the AI, you kind of know law, you can say content marketing, or you can say even the filmmaking in some sense. What are the industries you think that are kind of ripe for the AI-based automation system which are impacting right now?
Absolutely. So we should also acknowledge the 3-4 use cases which evolved in the 2000s as the first few largely deployed AI applications. It incidentally started with spam filtering. Spam was a big deal in early 2000s, and today you barely think about spam. Even the occasional distant Nigerian relative is no longer to be seen in our inboxes.
Yep.
And that was in fact the first real large-scale application of AI-based automation in learning new forms of spam emails and filtering them out. And then came the surge in online marketing, e-commerce, and social media, which largely used AI for product retargeting, advertisement placing, and marketing overall. And this also coincided with the wave of big data, and therefore the infrastructure required for training AI-based models with very large volumes of kind of activities, behavior of consumers online, kind of led to creating very large AI-based applications in that space. In this decade, there has been a strong wave of applications of AI in back office operations, especially operations involving supporting in verticals like manufacturing, happening in verticals like financial services, healthcare, and so on and so forth, which largely involves things like use cases like invoice processing, extracting signals from contracts, automating kind of configurations of contracts, and so on and so forth. Again, as you can imagine here, much like like a recommendation engine in e-commerce, the number of combinations is large, and therefore there is an element of learning that can help deal with the complexity of these business documents and business workflows. And AI has seen a lot of interesting applications and large-scale deployments in this space. Of course, on the consumer side, AI continues to push the horizon into use cases like face recognition, especially the Google photo or Facebook type experience that everyone has, apart from more near-term but still futuristic use cases like self-driven cars.
And what are the factors do you think that will impact the progress and scope of AI and automation adoption?
So I see 3-4 factors which need to be kind of addressed before the next big application of AI can go really production in big scale in a given vertical or in a given use case. The first and foremost, of course, is the skill. The ability to have people who understand and are trained in the science and engineering of AI. Work with people who have deep domain awareness. So, for example, we've seen that in the auto industry. All large auto manufacturers had to open offices in the Silicon Valley and bring people with deep expertise in kind of electromechanics of automobiles, in civil kind of planning and road engineering, and get those guys work with people who have background in image recognition and kind of model training in terms of kind of navigation and localization and so on and so forth. And therefore, this kind of creation of a skilled workforce that understands both AI and that particular domain is typically the first hurdle, which again needs the industry to kind of consciously invest in creating such skilled workforce and have them nurture in an ecosystem like Silicon Valley or Bangalore in India or other parts of the world where you can afford to have these types of skill sets come together. Of course, there's a strong element of data involved in making applications of AI robust. And it's not just the volume of data, but it's also the organization of data, and therefore the ability to label data in a way algorithms can consume and strengthen their predictive accuracy. And therefore, the consolidation and organization of data is kind of the second hurdle. And of course, there is a strong regulatory aspect, especially when use cases become more kind of critical and the risks become higher. Use cases like self-driven car, and we have seen the incidents that have happened, which has kind of pretty much slowed down the adoption of self-driven cars from a regulatory point of view. And therefore, especially in verticals like financial services, healthcare, logistics, there is a strong regulatory aspect that goes in. And as I described earlier, learning is in the very core of building AI into a application or a use case. And learning means committing errors, and error is the ingredient to a robust learning cycle. And whenever there is error, there is a risk associated with it. I mean, you don't mind an occasional wrong product being recommended to you or a wrong movie being recommended when you open Netflix, but you can't have the same latency for error when it's a healthcare or a financial services type vertical. And therefore, the sensitivity associated with error also creates a hurdle in more sensitive applications of AI.
And even I think the data cleansing and data mining itself has become a big industry because of the use cases that have been adopted by the AI. So
Absolutely.
kind of talking to the next point, the service industry example, how do these products transform the economics of the enterprise when you use them? So any examples you can give and then provide in terms of maybe taking a Peritas example?
Absolutely. So when you think of a modern enterprise, data and AI are seen as a factor of production. I mean, if you look at the traditional economics, you would just categorize capital, labor, and resources as three factors of production. I would argue that data and AI is the fourth factor of production. And when you look at any modern enterprise, like a Netflix and the FANG companies, right? The Facebook, Amazon, Apple, Netflix, and Google, all of these data is the first factor of production. Then comes labor, then comes capital, and they probably don't need any other resources other than the data they gather by their very means of digital operations. And this is becoming increasingly true in other traditional verticals. Like a bank today relies on data far more than anything else. Even 20 years ago, a bank would have relied on its influence on the regulators, relied on their network of relationships and connections, and so on and so forth. But today, you talk to you hear a JP Morgan Chase or a Goldman Sachs talking talking about their factor of differentiation. They only talk about data.
Yeah.
And I see that kind of moving into healthcare, moving into logistics, much like Uber or Airbnb, again relies on its access to data more than anything else. And therefore, at least in the last 10 years, I've seen data and AI becoming the first factor of production in several verticals, over and above the other traditional three factors of production. And in a services-oriented industry, it's always a very sensitive prioritization because labor has always been their first factor of production. And upskilling labor and the economics of upskilling labor, because you recruit labor in a semi-skilled state and through on-the-job training and your kind of differentiation in upskilling labor, you create highly skilled labor and therefore differentiate based on that. Now when data and AI start becoming an equally important factor of production, or sometimes a more important factor of production, it could shake the traditional premises of differentiation when it comes to services industries. And I think to a large extent, the advent of software as a service and usage-based consumption, even in large enterprises, has already kick-started this. Because if I'm a hospital network, I don't want to have a captive labor capacity locked in with a old traditional BPO contract. I want to have more of a usage-based economics where I pay by use. And I pay more in seasons where I have more demand, and in low-lying seasons, I don't need to have a captive kind of labor capacity anymore. And therefore, there are more natural market pressures on the service industry, which demand a more elastic, a more usage-based economy that the service market has to create for its customers. And that is the opportunity that has led to the adoption of AI in the services industry. Because by making data and algorithms the first-class citizen, either over or at par with labor, service industry can now provide that very value proposition of a on-demand, usage-driven economics to the customers of the services industry, which are pretty much every large enterprise in the world. And that is what has led to the advent of AI in back office operations, use cases like robotic process automation and so on and so forth. And Peritus, which happens to be one of my portfolio companies, which incidentally has offices both in Palo Alto and here in Bangalore, focuses on applications of AI in the infrastructure support and professional services industry, and especially with the adoption of cloud as a standard, as a new standard for infrastructure for all digital services. For example, every time you open your mobile banking app and send money through a digital wire transfer or payment mechanism, the backend infrastructure that is supporting all your actions and transactions most likely is sitting on a cloud. It's either one of the big three like an Amazon, Google, or Azure, or it's sitting in some form of a private cloud, like a PayPal or Paytm in the case of a major payment service provider or digital payment service provider in India. And therefore all that infrastructure of managing layers of software and hardware infrastructure that is becoming the backbone of all our digital services. Traditionally, there used to be a more human-centric set of support and professional services that would deal with incidents, outages, de-risk the operations of the infrastructure behind all these digital services. And Peritus essentially is addressing that market and harnessing value from data that is being generated in the forms of logs from all this software and hardware infrastructure, and use that to proactively assess incidents of risk, remediate those incidents even before they escalate, and even when incidents do escalate, automate a large chunk of the resolution of those incidents, and therefore kind of transforming a human-centric services industry with the help of data-driven and AI-driven digital approaches.
That's a great example. So in your own mind, what are the primary challenges in building this kind of artificial intelligence-based automation platforms today?
Yeah, as I was describing earlier, the ability to get the right set of skills together in a project or a kind of an endeavor in building such an application. So the skill set is obviously the first and foremost hurdle. There has been a lot of effort in encouraging the education around AI. I recently saw, even in my alma mater, IT Madras, there was this initiative called Padhai, very interesting wordplay, Pad AI, Padhai,
Okay.
as an initiative from the institute to promote students to take up AI in their courses, and I think even reach out beyond the students in the university. and through online and other channels. So upskilling the workforce with the knowledge and experience around AI is the first and foremost hurdle. The second hurdle, of course, as I described earlier, around regulation, and therefore educating the regulators around the inevitable applications of AI in different verticals and how to deal with the risks of applications where, again, as I described earlier, the process of learning and the errors that come out in the process of training and making AI more robust, and how to de-risk that, and how to augment the human-driven kind of cognition with AI so that any errors that might come out, there's always a human element to check the recommendations or decisions made through AI.
Preempt and then create guidelines maybe.
Absolutely. And of course, finally, as we had discussed earlier, the availability of data, especially well-organized labeled data. And there is an element of human services to reorganize data and make it usable by AI algorithms in the form of training better and better models.
Now, kind of understanding cognitive modeling, which deals with simulating the human problem solving and mental processing in a computerized model, seems to be a core component of this type of automation. Now, taking from there, what are the major achievements coming out in this area, and how do you see this progressing over the next few years or decade?
So when you look at AI, you can think of it in terms of three horizons, what we call narrow intelligence, general intelligence, and super intelligence. Narrow intelligence basically means that you are applying AI for a very specific task, which could be recognizing speech, which could be recommending a product based on behavior of a shopper, and so on and so forth. And general intelligence means you're using AI to almost replace human cognition. So the way our brain functions, it's a composition of dozens of different faculties. And as we are sitting and talking to each other, hearing is one faculty, speech is another faculty, vision faculty. The fact that we are balancing ourselves on these chairs is yet another faculty. A robot might just be good at just doing that, being able to sit in a posture and not falling off the chair. And therefore, general intelligence is a combination of dozens of different faculties which function with one another in a synergistic way all the time. And of course, super intelligence is when we combine faculties of a large fleet of bots and create super faculties that are beyond the reach of a human being. And this is widely accepted as three key horizons in the evolution of AI. So obviously, AI began more as narrow intelligence type applications, like the examples we discussed earlier. Could be spam filtering, could be recommendations, could be invoice processing, and so on and so forth. And today, AI has progressed to an extent where it can kind of address specific faculties, like self-driven cars. Driving a car is a faculty in itself. It's not just one task. It's a combination of dozens of different tasks involved in navigation, in visual faculty of detecting obstacles, in planning, and so on and so forth. And therefore, today, with use cases like self-driven cars, we have seen AI starting to own the entire faculty, not merely a narrow set of individual tasks. And I think that's a big progress from even 5 years ago, and that's almost, in my opinion, halfway between narrow and general intelligence. And therefore, I would definitely see the horizon of general intelligence being merely decades away from where we stand today. And in that meantime, we will see faculty after faculty be targeted through applications of AI. And again, more and more sensitive faculties be targeted. Again, the self-driven car itself is a fairly sensitive faculty because it involves real human lives. The risks associated with navigating ground vehicles on the roads is pretty sensitive. And therefore, you can now think about faculties in the financial services industry, like investment advisory, managing your pension plans, and so on and so forth. You can think of faculties in the healthcare industry, like providing care. May not be brain surgery to begin with, but at least the simpler faculties in healthcare that could be potential applications of AI. And we're already seeing applications of AI in bioinformatics, in genetics, in precision medicine, and so on and so forth, which are again kind of healthcare related faculties being addressed. And that's how I see kind of the evolution of AI as an evolution of more and more human cognitive abilities being delivered by AI-based approaches.
Diving deeper into the technology, what does the tech stack look like in these type of automation?
Absolutely. So when it comes to technology, again, there are horizons. AI began more as a simple machine learning approach in the late 2000s. And think of machine learning as the ability to provide weightages to a combination of a large number of signals and learning those weights. And therefore predicting a decision or predicting the outcome based on the learned weightages on different signals. So it could be as simple as, again, the shopping and recommending the products to shoppers type of example. So signals there are, the demography of the shopper, what the shopper has done in his or her own shopping history, the carts that are, left unfilled, and therefore, can be used as signals, and so on and so forth. And therefore, the ability to model the intent and the tastes and the preferences of a shopper involves assigning different weightages to each and every signal that you gather about the shopper himself or herself and his or her behavior. And this used to be the traditional approach of machine learning, where you kind of create a mathematical structure of weights and associate each and every signal with a combination of weights that you have learned. And therefore, when a new shopper comes, you kind of pick the demographic attributes of the shopper and pick the right weightage model that you have trained and learned from the machine learning approaches, and use that to come up with predictions about future behavior of the shopper. And the next horizon after that came something called deep learning. So deep learning, unlike machine learning, which is just learning of weights, so here it's not just a model of weights, but it's a model of models, and therefore there is a meta element associated with it. It is kind of the way your brain works. So when you look at somebody's face, you're not analyzing the face pixel by pixel. So you're making kind of coarser segments of the face, like the tone of the skin, the shape of the nose, the shape of your eyebrows, whether you have a mustache or not, the kind of hair you have, and therefore you kind of create 6 or 7 different models. And each of those coarser kind of segments of the face, you kind of apply your cognitive abilities to assess how each of the coarse fragments looks and feels like. And then using a combination of those assessments, you make an inference whether this person looks like someone you know or don't know, and so on and so forth. And therefore, even in that simple example of detecting somebody's face, there is the ability to first learn a smaller set of models and then combine those models and make a deeper inference about whether you recognize the person or not. And this was the inspiration behind the genesis of deep learning. Of course, this approach also has a long history. It's not something new, but again, because of the availability of large-scale data and infrastructure costs of training these models coming lower and lower, it became feasible for applying deep learning as a fundamentally more sophisticated and more evolved artificial intelligence approach. And especially 2015 is an important year for deep learning, because that is when there's something called ImageNet, which is like a benchmark for accuracy of face recognition and image recognition. And 2015 was the first time the algorithms proved to be more accurate than human beings in recognizing faces. Wow. So human beings, I think, have an accuracy of 95%. We tend to make 5% errors in recognizing faces. I'm sure every one of us who has gone through a wedding painfully knows the 5% error in recognizing, is this person related to me or my wife? Anyway, so in 2015, the benchmark that the algorithms beat the human bar of accuracy. And after 2015, the deep learning approaches towards face recognition have been consistently much more accurate than human levels of accuracy. I think as of now, it's almost 10 times more accurate. So I think the algorithms have error rate lower than 0.5%. And therefore, next time Facebook or Google says, there's somebody in the photograph, you have to believe it. It will be more right than you 10 times more. And that was a key kind of milestone for deep learning and artificial intelligence overall in proving to be more effective than human cognition, at least in that one faculty of facial recognition. Of course, it's not like self-driving cars have proven to be 10 times more effective. Maybe they are, but there is still a lot of data to be gathered to prove that. And that goes to my previous point, and this is kind of the advent of AI in the near future, where faculty by faculty, the evolution of AI will try to prove to be more effective than human beings, especially through applications of approaches and technologies like deep learning. I myself have applied a couple of other approaches that I'd like to call out, which I feel are paving the way for the next horizon. One approach is called transfer learning. The ability to build models in a particular domain or particular set of use cases and retrain them incrementally for a related set of use cases. For example, the ability to train models for a particular product category, could be like a grocery type product category, which kind of expresses the consumer's preference towards taste, preference towards kind of culture, and so on and so forth, and reuse that model in a category like recommending restaurants. So as you can see, grocery and restaurants are related to each other. So if you like to buy more spicy items, if you like to buy tangy items, there is a way to associate that with certain items in a given cuisine or a given cuisine itself. And therefore, this is, for example, this is a good example for transfer learning, where you train models that associate consumers' tastes with grocery items and incrementally train them to associate the consumer's tastes towards cuisines and food items. And this form of application has a huge amount of use cases, because there are a lot of use cases where you don't have enough data, but you might have data regarding a related use case, which may not be directly relevant to where you're trying to apply the artificial intelligence approach. And transfer learning gives you that mechanism of harnessing related data, if not directly relevant, but yet being able to create accurate enough models for you to address the given use case, like recommending restaurants. The other approach that I have been applying through my portfolio companies is the ability to separate knowledge from training. Because in every application of AI, there is obviously a set of facts, a set of domain-related knowledge elements that are already out there. You don't need to learn them, because they are already cataloged. You can buy a manual and read through that. Whether there are product attributes, whether they are design attributes when it comes to more kind of enterprise type use cases, and so on and so forth. And many times this knowledge is compiled for human consumption, like in the form of literal like manuals and Wikipedia and wiki pages and so on and so forth. But that organization of knowledge cannot really be used by algorithms for training AI-based models, and therefore you end up learning the knowledge about the domain through traditional kind of cycles of learning and error and so on and so forth, which I'm trying to avoid by creating graphs of knowledge. Think of these like ontologies, where you kind of organize knowledge in a hierarchical manner that can be plugged into a training process. And therefore, in examples like Peritus that you were bringing up earlier, where we are trying to automate the service and support of infrastructure, and infrastructure obviously involves kind of software packages, hardware appliances, and so on and so forth. And each of these systems have their own nuances around design. Which involves how the system is architected, who's the manufacturer of the system, how does the system behave generally, what kind of log format it has, and so on and so forth. And this knowledge is already available. I mean, if you open the user manuals, API documentation, design manuals, and so on and so forth. And therefore it's inefficient to try to learn this knowledge through traditional approaches of AI, because this knowledge is factually available, deterministically available. You don't have to learn it in an error-prone cycle. And in use cases such as that, we take this approach of separating the knowledge about the entities involved in the application of AI from the training itself. And therefore, the knowledge graph becomes an input factor, an input signal into the application of AI through training, selection, and serving AI-based models. And I feel that's going to be an increasingly more important aspect as, again, we go into more sensitive domains, like financial services, healthcare, and so on and so forth. And in a way, it also kind of mimics how human cognitive abilities grow. I mean, you go to school to gain knowledge. and then you gain experience and learn lot more on the job. But if you eliminate the role of the school and you send kind of untrained but yet smart human beings directly to the job, then their ability to be efficient will be a lot lower, because there's only so much knowledge they can learn on the job. So think of this approach as being analogous to the way human cognitive abilities grow. And therefore, these are kind of elements of AI technologies that I feel will pave the way to open up new faculties that can be automated by applications of AI.
So then it is better to ask Siri when you can't recognize somebody than your own cognitive skills.
Absolutely. Let me add an example on that angle. So when you search for a movie or a person on Google, you don't get a bunch of websites. You get a knowledge card.
Yeah.
So when you search for Deepika Padukone, you don't just get websites where she's been tagged. Whereas if you think of it, even 5-10 years ago, Google just used to do that. Google was a PageRank algorithm, which gave you the most relevant website or asset in the internet that linked to a particular search term. But since I think about 2012 or 2013, you no longer just get that. So when the item that you're searching is very popular, Google generates a knowledge card for you. And this is an example of separating knowledge from the model. Because Google inherently has a knowledge graph internally that it's constantly building and maintaining and adding new nodes to. And when your search term hits one of those knowledge items, it no longer needs to serve you just websites. It can just expose its knowledge graph to you. And I think I should have given that example earlier. So what I'm trying to do is take that approach in other faculties, not merely search, internet search.
Shifting gears a little, there's a lot of talk on how automation is going to destroy millions of jobs. Do you think AI-based automation can augment jobs rather than job destruction? Can it contribute to job creation?
Yeah, the going belief is that every application of technology has destroyed certain lower skill jobs but generated a lot more higher skill jobs. And that's an empirical belief that all of us involved in technology generally, go with. And when you look at the evolution of automation, it kind of began with the first mile, like production, whether it's manufacturing, whether it's natural resources, and so on and so forth. And then off late, it's gone after the second mile, which are all the supporting functions around production, back office, IT, HR, and so on and so forth. And therefore, it's pushed the first mile automation pushed jobs into the second mile, and automation in the second mile is now pushing jobs into the third mile, which is literally the last mile from what we have seen, like your Swiggy delivery boys to Uber drivers to a lot of kind of last mile logistics oriented jobs which are created because of the massive scale of digital operations all these platforms bring, like Uber, Airbnb, DoorDash, Swiggy, and so on and so forth. So it's hard to imagine what is the next mile because now AI is really after the last mile itself, with self-driven cars, with robotic logistics, and so on and so forth. There's obviously, as we discussed earlier, the opportunity of data operations, data labeling, data organization. But I believe that opportunity exists because there is a massive volume of data generated by human beings that need to be consumed by machines. Or volume of data that's generated for human consumption that has to be repurposed for consumption by machines. And therefore, there is a big challenge of reorganization of data that obviously could lead to some jobs in the near term. But my opinion there is that, again, in the medium term, there won't be as much human-generated data left. For example, every time you would go to a shop, you would have an invoice or a receipt. And scanning that receipt for filing an expense report or scanning the receipt for filing your tax returns did involve, again, data labeling and converting that physical receipt into a digital asset that can be used for automated, tax filing or expense filing and so on and so forth. But increasingly today, your shopping experience itself is so digital that you don't have that, human-generated receipt anymore. Like every time you hail a ride in Uber, where is your physical receipt? The receipt itself is a well-annotated JSON object which doesn't require any more labeling. And therefore, I'm sure Uber already has integrations into your expense systems and tomorrow into your tax systems. And therefore, in the process of including all your Uber trips in a given year as deductions in your tax filing, there is no scope for any additional data labeling or data organization left. And I feel increasingly all the data that is going to be generated in the next coming years will be generated by digital services, will be generated by algorithms themselves, and will be at the source well labeled and well annotated. So therefore, this whole gap around data labeling, I feel could be a very short-term gap, and in the medium to long term might disappear. So I feel at this point in time, we are not fully aware of what is that next mile of jobs that the current state of AI-driven automation would create. And of course, there is a lot of talk about what will happen to these jobs and how do we deal with the large-scale macroeconomic impact of the advent of AI. In fact, right before the end of his presidency, President Obama gave an interview with a couple of journalists from Wall Street Journal, where in fact he openly talked about social security tax on automation. So that for every faculty automated by AI, you kind of create a social security related tax that covers for the job that is lost and paying the social security for the workforce who lost their jobs. And in fact, if such a global leader is already thinking about a plan or an idea as radical and as extreme as taxing the robots, I personally feel I have mixed feelings around what could be the next horizon of new jobs being created.
And do you have any thoughts on the state of AI based automation in India, and how does it compare with the US?
Yeah, so India is the back office of the world. So all these back office related applications of AI still needs to rely on the domain expertise and the experience that Indian workforce has. And therefore, the giants in business process outsourcing, like the Genpacts and WNS, Wipros of the world, they, I feel, hold the key to making AI applications scale in back office automation. And in fact, at least to my knowledge, they have been quite forthcoming and open in embracing the power of AI in those types of applications, largely because of the other comment I made about the market pressures that are affecting the services industry. And of course, there's been a lot of public kind of open discussion and the impact of this pressure on the big kind of blue chip companies in India, like the Infosys, Wipros of the world. And therefore, I think these institutions are openly embracing AI as a response to the market pressures. But they also hold the key in making AI really work as an approach towards back office automation. Apart from that, India is obviously also a big consumer market. I think we crossed US in terms of number of internet connected users. And therefore, any advent of AI in consumer facing experiences, all the way from self-driving cars that we discussed earlier to, more traditional use cases around recommendation and so on and so forth. I think India remains to be a dominant market for evolving those technologies. And finally, India also is the home for, I think, the largest number of, most popular languages in the world. And I think recently I saw, a UNESCO survey of all languages which had, I think, more than 40 million speakers. And I think that included at least half a dozen Indian languages apart from Hindi, also including, Telugu, Bengali, Tamil, Marathi, and so on and so forth. So I think a lot of advancement in natural language processing, speech technology, and applications of AI there, India will again have an increasingly important role to play, especially as the demography of the average internet user is more diverse today, and especially with the advent of platforms like WhatsApp. There are obviously a lot more non-English speaking users connected to the internet from India than ever before. So I see these being kind of very important domains where India could play and will play a leading role in evolving applications of AI.
To end with, what are you seeing in terms of the broader trends in AI based automation, and where are we headed in the future? Just taking an example, maybe for about next 15 to 20 years, what do you think is the trend?
Absolutely. So as I was describing earlier, I'm always looking out for the faculties that are getting impacted or that are getting more sophisticated with the applications of AI. In terms of enterprise-oriented faculties, I'm looking at different flavors of services and more ambitious set of services that could benefit by automation and augmentation with the help of AI. One such service that I'm looking into right now through a portfolio company is that of business process transformation. So this whole SAP, Oracle, Salesforce kind of led business process management industry survives on consultation based transformation, and therefore there's a lot of human human-centric and knowledge-centric work that helps enterprises build better, more sophisticated, more efficient business processes. I feel that's a faculty, and we have demonstrated that in specific use cases. That's a faculty that could benefit through applications of AI. So this company is called Live Objects, which applies AI in core business process blueprinting and business process optimization. And is looking into today more vertical agnostic use cases, like finance, like order management, and so on and so forth. And I feel AI can kind of push the envelope further in more domain sensitive verticals like manufacturing, supply chain operations, procurement, and so on and so forth. So this is one horizon where I definitely see an evolving role of AI in addressing more challenging faculties. The other, of course, is more around logistics, especially that touches the physical world and physical world's operations. So, of course, the self-driven car not only impacts consumers, but it also has applications in the industry like mining, B2B transportation, logistics, and so on and so forth. I'm also equally interested in applications of AI in the core industrial verticals. So the industrial verticals, it's been interesting because there has been a lot of adoption of AI in the operations side. And I think you were part of the journey, companies like Flutter and Altezon here in India, which took applications of AI into hardcore industrial operations, whether it's oil and gas, whether it's manufacturing, and so on and so forth. There I'm looking, again, pushing the envelope further, from operations into design. So what could be the role of AI in designing industrial processes, whether it's control automation, whether it's actual kind of electromechanical design, fluid mechanical design, and so on and so forth. So there I've co-created a venture recently in collaboration with a professor in University of Michigan, which looks into augmenting traditional physics-based simulation and design approaches with artificial intelligence.
Wow.
And therefore looking at very complex physics models, like a fluid dynamic model, which involves equations like Navier-Stokes equations, which are not even proven to be convergent in all cases. So these are very complex mathematical structures that kind of model the laws of nature in helping simulate industrial scenarios, which again are governed by the laws of physics, and using that to optimize industrial design. So this has been largely an engineering physics-based approach of analysis, simulation, and therefore design. So with the help of my co-founder and the research that he has led over the last decade, he has found approaches where you could simplify these complex mathematical structures with simpler parameters that can be trained using data, and therefore a very complicated 300 million cell mathematical structure can be simplified into a 500,000 or 1 million kind of point structure.
Wow.
With parameters that act as proxies of more elaborate mathematical structures. But these parameters can be trained by using operational data. And therefore, I might be building a structural model for an electric circuit that is tied to a motor or a drill bit in the case of oil and gas. And this can be used for training the inference of structural faults and degradation that come because of the vibrations coming from the industrial operations. So traditionally, this used to be a pure physics and engineering physics approach.
Yeah.
And because of that, it was computationally very complex, involved largely supercomputers and very large-scale computation infrastructure. But the application of AI can so drastically simplify these mathematical structures that now a lot more inferences can be derived. So therefore, here, by applying AI, you are affording lower fidelity of the physics-based model, but you are more than compensating for the loss of mathematical or physics fidelity by the diversity of data you can use to train these parameters. And therefore, diversity and volume of data compensates for the loss of mathematical fidelity in these models. And therefore, in a way, AI is simplifying kind of the engineering and the mathematics involved in applying laws of physics in industrial and commercial use case scenarios. And in fact, we have kind of increasingly seen that even in astronomy or even in fundamental physics. For example, the way you detect the next astronomical event is no longer by peeping into the sky with a telescope. You get a large volume of signals in the form of data, and you use algorithmic approaches to discover the next big kind of cosmological or astronomical event. And when we are kind of taking a similar approach but focusing more on commercial and industrial use cases. This venture is called Geminis, and I co-created this venture more recently, late last year, and we are looking at right now very narrow use cases when it comes to applications of fluid dynamics in pump operations, in predicting cavitation and other events in pump, ability to use this approach to recommend control automation upgrades, like if a valve is misconfigured, being able to discover that misconfigured valve in a pump and recommend upgradation of the control logic operating that particular valve, and so on and so forth. But obviously with the vision of going a lot broader in the coming years, and therefore another faculty, industrial design obviously is a centuries old human faculty, where I strongly see the role of AI in augmenting and automating aspects of that faculty.
Thanks, Kamesh, for your inputs and insights on this, and best of luck for the Geminis.
Again, I appreciate this opportunity a lot, and it's been a pleasure to interact with you and your community, and look forward to more conversations in the future.
Absolutely. Thank you.
Thank you for listening to the Ideaspring Capital podcast. If you like this episode, please subscribe to the show, and do leave us a review and rating on iTunes, Stitcher, or the app that you're listening to this on. Additionally, you can get in touch with us on Twitter at IdeaSpringCap. That is IdeaSpringCap. This podcast was produced by Scapari, your complete digital marketing agency.